Welcome everyone for joining. I know that we're seeing some additional participants come in, but as we do, my name is Elisa Rocha. I am the co-chair of the AIA Oregon Committee on the Environment, and we're really excited to bring this presentation to you. Before we begin though, if you could just take a moment to read the AIA Oregon Community Agreements, that would be fantastic. And
It's starting.
So we'll give folks just a couple more minutes. Okay, and just to reiterate, we're gonna start the presentation, but if you can take just a couple minutes to read the AIA Oregon Community Agreements, we'll kick it off. And okay, so thanks everyone for coming in today. This is our AIA Oregon Digital Design Series, Designing Daylit, Glare-Free, Energy-Efficient Buildings in Budget. So technology recommendations, please remember to mute your mic during the presentation and unmute your mic during the Q&A,
Great.
during that part of the
Thank you.
discussion.
I'm also concerned I got.
Oh, it looks like we actually have a little technical difficulty here. Did you mute? Okay, perfect. If your technology supports it, we'll welcome your camera being on during the presentation as well, if that's what you choose. Set your camera to speaker view during the presentation. And this presentation is being recorded. So we just wanted to make sure everyone is aware of that. And CE credit is available for the presentation. So make sure your first and last name is visible as your screen name so that we can take attendance. The AIA Oregon Community on the Environment brings this presentation to you in collaboration with COTE. Again, we're really excited to have them here. In this session, we'll be diving into 2 case studies, ways to generate beautiful analysis graphics and see how to shape the narrative in data-driven design processes. While I'm just going over this, I'd like to mention that the Committee on the Environment is an open committee. We're always looking for additional participants in the committee. We meet once a month, third Thursday. You can find registration for those meetings on the AIA Oregon events page. But it's a really great group of people. We're trying to do some really good work in Oregon, and we'd love your participation, enthusiasm, ideas, and so we can, continue the good work. So with that, I will.
I'm talking to teams.
Next slide. Upcoming AIA Oregon events, Thursday roundtable, Path to Fellowship, refining your opening statement. So FAIA members from Oregon and your CEO EVP Heather Wilson will be presenting the next installment of the 2022 Fellowship Application Series, refining your opening statement on July 14th. So this one is something that would be really great for you to participate in if you're following that path. The AIAO Small Firms Exchange, Wifter Bulch Architecture, is happening July 18th from 12 to 1 p.m. It's a virtual event. Let's consider the Birch ADU. Our speakers in July will be Jonathan Bulch, Colin Christensen from Wifter Bulch Architecture, and they will be discussing their involvement and award from a recent competition, the 2021 Salt Lake City Empowered Living Design Competition, centered on small scale design and affordable housing. So this one's also something if you can find on the AIA Oregon events page website and click in and register for that as well. Another upcoming event is the Urban Design Panel, Reimagining Public Safety and Security on Transit, July 19th. TriMet, the operator of mass transit in the Portland region, is committed to ensuring a safe, welcoming, and equitable transit system for everyone. This month's urban design panel will explore how TriMet's transit, equity, inclusion, and community affairs team is engaging with the community to reimagine a better transit system that is fair and free of bias, while addressing the needs of its riders and employees to feel safe. And my slides are not progressing. One moment. Here we go. Finally, wonderful. And now I would like to introduce tonight's speaker, Marco Aguirre, Research Director. He is the Research Director at cove.tool and has been with the company since 2018. He holds a degree from the Rhode Island School of Design, where he majored in architecture, Bachelor of Architecture, and digital media, BFA. At cove.tool, he coordinates the research, design, and development of all new features and workflows, as well as creating articles and videos on various topics such as sustainability, building performance, new technologies, and best modeling practices. He's always happy to contribute to forums promoting better practices and hopes his contributions make building analyses more accessible, intuitive, and easier than ever before to integrate into the design process. So now, without further ado, I will introduce Marco. And again, so excited to have you here. Thank you. Marco, you're on mute.
Sorry about that. Yeah, I just want to say thanks to the COTE Oregon team for inviting me to this session. My name is Marco. I'm the research director, as you saw in that last slide. For today's session, I hope to educate a lot of you on building practices for performance analysis, how to integrate into your design, how to design for daylight, for energy. Hopefully we just demystify some of this modeling practices. A lot of folks have deterrences and hesitations around this, but hopefully we can show the business case of why you want to do it, the kind of graphics you can generate, the more confidence you can build in your decision making, and then showcase actual projects that have followed this workflow. If you haven't heard of cove.tool, we are a building performance platform. Everything is online. There's a lot of different ways to plug into the cove.tool, a lot of different simulations and tools you can use, and I'll showcase some of those throughout today's presentation. If that sounds good, I'm going to showcase the agenda really quick. So today we're going to talk about some of the issues with the industry and really why we want to incorporate more analysis. I have a couple of slides talking about the business case of incorporating sustainability and how that can impact your market value and business growth of the products you deliver, or your own business growth and the market value of the products you deliver. We're going to talk about different performance metrics you need to know more about, specifically how energy models work, daylight models work, quality analysis, and carbon studies, and what it means to run those types of analysis to make decisions about your building and how you can communicate that to your project team and clients to have a more effective conversation. We'll talk about the collaborative workflow, how to deliver an integrated project delivery team, what that looks like within this kind of workflow, and then finally just close out on some case studies. At the end, we'll open up the floor for any questions that you might have for me. And if you'd like, this presentation will be available, and I think they're also recording. So yeah, let's get into it. What's the challenge? Well, the biggest challenge right now is that buildings are considered over-contributors for the climate crisis. About 40% of total global carbon emissions and 76% of electricity usage in the US are coming from buildings. At least half of these buildings that are going to be built or going to be around in 2050 have already been built. So anything we can do to help make the new construction more efficient and any renovations pinpoint the specific upgrades that they have more efficiency, lifespans, and reduced impacts on the environment, the more we can fight climate crisis. We already are aware of a lot of the different situations and conditions that are going to happen, and are aware, according to the IPCC report, of what we need to do in order to decarbonize the industry and make our buildings more efficient. But right now we are on track to hit a 1.5 degree increase in the globe. This increase in temperature is going to have direct impact on the environment, on the economy, on the health of occupants. We're going to see more impacts to where we live, where we work, how we raise our families. And if us as the ASC industry, specifically architects, can have any influence, it's really on the design that we are, how we're designing our buildings and the approach we have to the projects. What I'm going to be talking throughout today's presentation is about performance analysis. Right now, only 50% of architects ever run analysis on their projects. Typically, when you do run analysis, it's after the project's been designed, after the DD into the CD phases. And if we are able to run analysis sooner as we're making decisions for the project, the more impact we can have on the building's performance and cost. Some of the deterrences that we've heard about incorporating more analysis and performance modeling it and doing it in-house rather than hiring outside consultants is that it can be incredibly expensive. Either you're hiring consultants or you're trying to buy the software in-house. It becomes incredibly complicated. You don't really have the expertise or degrees to go into these different tools. Some folks think it's unnecessary. If your clients aren't asking for it, it's not a service that you're interested in providing. And also that it's for specific types of projects that you might not be working with, like large scale projects, specific use types, big budgets, institutional clients. Well, all of these things we're hoping to help combat with more education and with the delivery of better products that can make it more accessible, democratize the building analysis industry so that more folks can do it and we have a greater impact on how many projects are actually run through these analysis models. Before we get into the breakdown of different analysis, I'm going to talk about the business case of what it means to deliver a green building and how it can help your business growth and the market value for your clients, the return on investment that they have when they go for a green building. One thing to note, first and foremost, is that energy codes every year are getting more and more stringent, especially in Oregon. I'm very aware of the constant energy code changes there. If we don't continue to educate ourselves and better understand what kind of technologies and strategies we need to incorporate into our building designs, the harder it is to continue to deliver buildings, meet code minimum requirements, and then win future projects for our firms. Back in 2003, when the CBEX baseline was established, we saw right after a 5% energy reduction for the requirement of buildings. In 2010 energy code, we saw a 30% reduction. Right now, most US states are following a 50% reduction of energy codes for code compliant buildings. And we're starting to see that trajectory move to 100% or net zero designs. This is partly instigated by the 2030 challenge, which a lot of you at the COTE committee might be aware of. And then also authority figures like the ASHRAE decarbonization team talking about the resources, the skills, and the legislation that needs to happen in order to require a bigger action from our industry to make sure we decarbonize the projects we're delivering. One other aspect is owners are asking for sustainability. Back in 2019, cove.tool held a survey of over 1,000 architects and engineers from North America, and half of them let us know that in RFPs, sustainability is being requested half the time. And we do have an idea of why that might be. There's a lot of research and studies out there showcasing the increased market value of buildings. There's a lot of different stakeholders that are attracted to living and working in more efficient buildings for tenants. Green buildings tend to be healthier, more productive spaces to live in, to work in. They have lower operational costs, lower maintenance costs for owners, developers, investors, developers. These green buildings can sell higher, they lease faster, they have higher rent values, they last longer, lower depreciation. It's just a greater return on investment for all those who are going for a green building project. We also see the impacts on rental and occupancy rates. So more folks are moving into more efficient buildings. We're starting to see a huge difference between the occupancy of the green buildings versus what we're calling the brown building industry now. Brown buildings being buildings that are just code compliant or being built the way that's traditionally been done. And they're selling, leasing far less than the buildings that are pursuing things like green building certifications or going after more stringent targets. And then finally, this is coming from the 2021 AI report for technology, culture, and the future of the architecture firm. One of the biggest indicators for profitability and efficiency for firms across the industry was whether they were able to demonstrate strong project management skills and also showcase real-time insights that were able to meet the client's needs. These two features are all about technology, making sure that you can communicate effectively through technology. You have more analysis, or you have more tools in order to look at where the building's at, make changes, see what the impacts will look like for your project team or for your client. Yeah, that's going to be a huge differentiator, what kind of technology portfolio you have in order to deliver better buildings. And now with that kind of business case out of the way, I want to shift a little bit more to focusing on performance metrics and really talking about what is analysis, how do you use it, what are the metrics you should be concerned of as you are going through the different design phases. First, I just want to talk about what exactly is a performance analysis, or what is a simulation model. They have a lot of different names, but a performance model is the approach or the 3D computer model that iteratively tests, analyzes, and improves your design. If we can integrate it earlier, we can have more impact onto the decisions we're making, which will have an impact on the final performance and cost of your project. Why is performance analysis important? Performance analysis lets us predict where our building is going to conclude on, and also we can have a better idea of we're on track for certain changes. One of the biggest reasons projects go over budget is because they're not able to hit their project goals, and you have to go back to the drawing board, or you're constantly leveraging one design feature over another. And if for other folks who are currently working on projects, green features or one of the more design features you care about most are often the first things to get cut. If we're able to run analysis, make sure we're on track to hit all of our targets, the more of those features we can integrate and the more risks we can mitigate with the incorporation of analysis. And then hopefully with incorporating more analysis, the more confidence it grows in communicating with your different collaborators. So it's also not just talking to your client, but being able to communicate with the same vocabulary to your engineers, other consultants, specialists, cost estimators, so on. One caution I always like to let folks know about is that performance analysis is not an exact prediction. This is something every energy modeler, daylight modeler knows about. This is just an assumption made on characteristics, anticipated patterns of use. We can get an idea of where the building's going to perform, but once it's actually built, things might change because of construction practices, because of how the occupants decide to use the space, or because of extreme weather conditions. Every year things change. We can't predict exactly where it's going to go, but analysis is one of the best ways for us to assume if we make these right decisions. And if we look at option A, option B seems to be the most effective. That's the best way we can deliver a better building. It's not about getting exactly to where the model says you're going to get. And I know this is one of the things that always concerns architects who haven't done analysis. It's one of the things that keeps them from ever integrating analysis. Talking about analysis, here's some of the top areas of analysis. So here's some of the more popular ones in energy, water, ecology, wellness, equity, predictive. The platform I work for at cove.tool, we're only tackling the ones that are more building focused, like energy, water, and some wellness. But there's all other different platforms that are incorporating other things like ecology, equity, different health assessments, occupant assessments, your occupant comforts, things like that. Hopefully cove.tool can help service a lot of your needs, but we also collect a lot of different free resources that you can use in order to make your process better and just wider approach to things. Next, a lot of folks also ask, when is it they should be doing analysis? This is a process that begins at the beginning of the project, ends with the end of the project. It happens at every stage of design. This is a really great graphic from the Architect's Guide to Building Performance, which was an AIA publication. It was meant to be annual, but right now they've only ever done one. But it has a lot of great graphics and chapters explaining what exactly performance analysis is, when you should do it. It's a really great place to get started. This is one of my favorite pages, and it just showcases over the different design phases, what studies you need to do, who's responsible for them. And just notice at the bottom axis, architects are never not playing a role. They're always active, they're always informed, working with the building performance specialist in order to make decisions. But the architect does have a major role in massing, orientation, ventilation, shading, daylight, envelope, thermal comfort. And with the help of cove.tool, we can also give you more tools for energy modeling, concept design, load reduction, HVAC systems, etc. We're primarily focused on the earlier stages, but we're going to keep growing to cover more of those areas. But just want to showcase this graphic. Some of the key metrics to track and look out for. We're going to break down these metrics in the next couple of sections. Energy use intensity, which is how much energy your building needs in order to operate per year per square foot. Your 2 daylighting metrics, SDA and ASC. That's calculating or measuring how much daylight do you have. Is it sufficient? Is it during the hours you need it? And then embodied carbon, which is the carbon dioxide emissions or the greenhouse gas emissions of your building through the different stages of operation, or embodied through material selection, things like that. So let's start with energy. Energy is probably the most intimidating of all the different building performance analysis. It's easy thing to hand off to your engineer or your energy modeler, but hopefully we'll give you some idea of how easy it can be to understand these concepts and then start making decisions for your building. So first things first, what is an energy model? An energy model is just a calculation of heat flow in and out of the building. Imagine where you live, you place a box, and in order to maintain the ideal comfort within that box, you have to apply certain strategies in the insulation of the box. During nighttime, you need light, so you need lighting. In order to keep it cool in the summer months, you need air conditioning. In the winter months, you need heating. And then hot water, all of these different things in order to maintain ideal comfort based on your outdoor conditions. That's basically what an energy simulation is doing, trying to figure out based on the standards according to your energy code and other assumptions that we need to make. That's how much energy we need in order to operate your space over a typical year. The energy, the metric that we're measuring energy consumption in is EUI, or energy use intensity. And that's specifically the different categories within your building that requires energy production. So we have space heating, space cooling, pumps and fans, lighting, hot water. We have all of our equipment or plug loads. And then also another part of calculating energy use consumption is if you generate any energy on site. So if you have solar hot water or PV panels in your design, we calculate everything that is consumed and also anything that's generated, divide that, and that's how we get your EUI. One of the great things about calculating EUI is it really lets you know exactly what parts of the building you need to improve. So I have 2 graphics here. We have a breakdown of your EUI and a benchmark of your EUI. First, the benchmark gives you a spectrum of where your building performance currently is, where it should be, and where everyone else is. So we have something called the CBEX, the Commercial Survey for Energy Building Consumption, or building consumption. That gives us an idea of the national average for a building of your size, your typology, your location. If you're reporting to the 2030 DDS, this is also a number you'll see. And then right now, the target for where most buildings in the US should be in order to hit decarbonization and carbon emission goals is an 80% reduction of that number, which is that 2030 target. So, and then based on all of your current strategies, where your EUI is. So you know where everyone else is, where you should be, where you are, and then your EUI is broken down into these different categories: cooling, heating, lighting, equipment, fans, pumps, hot water. And then based on what's dominant, so in this case, it's probably in an island project, we have dominant equipment, dominant heating. We need to incorporate more strategies like possibly passive solar heating, so bigger windows, maybe less insulation in the roof or in the walls, depending on where you're located. And then for equipment, going and purchasing more efficient equipment, like requiring Energy Star appliances across your whole building. That can be a really easy way for us to pinpoint exactly what we need to do. And it's a decision the architect can make and then relay to the other teams, and also helps us identify what strategies we need to do in order to hit the 2030 target or even go for a more efficient design. So how do we make energy modeling easier? The one answer is automation. We need all of the standards have already been written. We know all the assumptions we need to make. Buildings don't really vary too much. So with all the information that we already have, we can pre-populate a model, and that's what COTE is doing. We automate all of this information with very few assumptions, just your location, your geometry, your typology, and your energy code. That's enough information to populate all the different decisions, factors that go into your project, and for you to start iterating, moving through different options. The idea of figuring out what exact upgrades you need to make in order to make your building more efficient, this is called an energy conservation measure, or ECM. And this is really what the architect needs to learn about and understand in order to incorporate and deliver better performing buildings. So you have things like more efficient lighting, thermostat controls, sub-metering, more efficient appliances, green walls, low flow shower heads. You'll see some of the top ones. Here's a screenshot of the COTE platform within the energy modeling page. You can see all of the different inputs. One thing we do to make sure folks know what they're doing, what they're looking at, is each one of these question mark icons has an explanation and a more detailed article to explain what it means, what you should be doing, how to communicate that information. The top inputs you should always look at and just keep in mind as you are designing a building and trying to get that EUI lower is looking at the envelope properties. That's your roof and wall R values, your glazing U values and SHGC values, the appliance power density and lighting power density, which is the watts per square foot that's required from each one of those systems. The number of people that are in your space, that might not be a thing that you can change, but it does directly impact how much energy is required, how efficient the systems have to be, or how much do they have to work during your typical schedule. And then your system types and COPs, which is all of the HVAC settings. One nice thing that we do with COTE is we simplify it down into just a couple of inputs. So these 4 inputs are the primary factors we need in order to describe your HVAC system and let you know how it's going to perform and affect the rest of your building. Simplicity is key in order to make these decisions and actually have an idea of where it's going to perform. I already talked about that. And of course, knowing more of this, understanding how the different factors react with another, you can pinpoint exactly what you need to do in order to hit the 2030 target. A lot of architects get frustrated when they realize how far they are from the target. They think it's unrealistic. We have a lot of different training sessions. I've written a lot of ebooks and video tutorials on how to try to attempt the 2030 challenge, what you need to look at and incorporate. But it's moving beyond the design and looking at systems, HVACs, lighting, and the way we've simplified it, hopefully it's more accessible to architects. Here's an example within the platform, specifically targeting things like changing insulation, just changing that R value, installing daylight sensors, occupancy sensors can be really effective. Lighting power density, solar panels, you can make those small incremental changes, hit recalculate and see how that affects your performance. If it's not enough, you can add additional insulation, add more solar panels, see exactly what you need. Or if it doesn't seem to have any impact, then you can save your money. And instead of investing for more efficient glazing, because it's not going to have an actual impact, but it's going to cost you a lot, you can look elsewhere within the building design. And then, of course, there's a lot of benefits to running energy analysis. It can help reduce operational costs. Here's a quick graphic of residential projects and their energy consumption, and then the impact we can have with pinpointing specific upgrades within energy model and how we can reduce the energy bill. So this is a 30% reduction with residential projects. It's hard to do that same kind of study with commercial projects. Get the idea. And also they have lower life cycle costs and easier to maintain over time because you've already invested for a better project at the beginning. I'm just showcasing those values. So that was the energy modeling. So modeling, again, it's just a software prediction of the pattern of controlled daylight coming to your space. It's all about looking at quality and so how much light is it coming in, and is it the kind of light we need? There's a really big difference between and non-beneficial. Beneficial is where you can turn off all of your electric lights and the space is well lit by the sun. And then non-beneficial daylight is where it gets really uncomfortable. It's a lot of glare. People tend to pull down the blinds, wear hats indoors. It really destroys a lot of beautiful spaces because they didn't think about daylight modeling and figuring out whether they needed a shading strategy. The two metrics we use to measure daylight and glare are SDA and ASE. SDA is spatial daylight autonomy. This analysis breaks up your floor plate into different grid points. Each one of these grid points are depending on grid size. So in this example I have here, this is a 2x2 grid point, which is the average diameter of a person. So each one of these grid points just represents, if I was standing there, how much daylight would I receive on a typical year? Depending on whether you're receiving sufficient daylight, which is around 300 lux, and if you're receiving 300 lux over 50% of your time there, that's what we would consider a well daylit space. So that's where you get these yellow, orange, red colors in our legend. And with other tools, you'll see how they display that information. But it's just measuring how much you get and whether it's good, what the quality of daylight it is. The second daylight analysis, ASE, annual solar exposure, is looking for glare. So glare is what we'd consider 1,000 day lux or 1,000 lux, and we're measuring it in number of hours. So if you're having 1,000 lux for over 250 occupied hours, that's an incredibly uncomfortable space. That's where around usually from 3 to 5 p.m. On southern western facades, people get really uncomfortable. It's hot. Again, these are just uncomfortable conditions for your occupants. It's something that you want to think about, and also can increase your cooling loads as you need additional air conditioning in order to make that space more comfortable. There's a lot of benefits to running energy daylight models. They can have an impact on the occupant's health, the happiness, the productivity. Here's all the different studies we referenced for that. And you can just imagine how great it would be to eat in that space, work in that space. Another analysis I kind of want to slip in here. This is just the potential of what incorporating more technology is within your design process. A lot of folks have never run a views analysis, but it's something that technology is making it easier to do than before. If you never heard of a quality view or views analysis, this is the ability of a software to check what kind of views your occupants are receiving, whether they have 90-degree sight lines, which is I can see one view 90 degrees wide, whether I can access the sky, whether I have context, and whether I have any obstructed views from the inside of the building. This is something that we've been able to automate using ray tracing. Ray tracing is a technology that the gaming industry invented. It's something we incorporated to make our simulations faster. And traditionally, as in within 5 years, the way to do a views analysis is just to take paper, pencil, a 90-degree triangle, and then figure out what kind of views your occupants have. So this is saving a lot of time. This is one of the fastest tools to do this view analysis. We're also one of the first to do it. And it just showcases the potential of it. And of course, again, there's more benefits and market values that you can show to your clients for the kind of spaces you have. Buildings with non-qualitative views are incredibly uncomfortable. They don't look nice. They tend to cause depression. There's a lot of studies kind of showcasing this. We use green building certifications as a reference point, but not every building can afford to go after a certification, but it also should be something that you use just as a market argument. So if you're not going to go for that certification, then just showcase, hey, I still was able to design this quality view building with a lot of daylight. It's energy efficient. Those are the kind of features that building owners are looking for when deciding who's going to get what project. And then the last metric we're going to talk about today is carbon. Again, this is another metric that not a lot of folks understand, but it is one that's going to become more and more popular. There's a lot of conversation about requiring legislation for carbon emissions of buildings. There's a lot of competitions around the world that now only allow buildings or architects submit if they can calculate for embodied carbon and also energy. So it's going to become more and more of a thing that you need to know about and then eventually calculate for your buildings. So what is carbon? Just to get to the really basic level, carbon or carbon emissions, also known as carbon footprint, is the impact of a human process has in emitting carbon dioxide or equivalent greenhouse gases. If you don't know what a greenhouse gas is, it's a specific type of gas which, because of its material properties, it maintains a lot of heat and energy, and also because of its density, floats into the atmosphere. So it's a gas that gets really hot, goes into the atmosphere, stays in the atmosphere, and because of that, it's causing the global warming and also all of the differences in climate change. This has become really popular as of late. Of course, because of the worry about the temperature difference between where we're currently projected to hit that 1.5 Celsius degree raise versus that 2 Celsius degree raise. And this is a great graphic from the wildlife, I forgot the W is, but the WWF of the impacts the 2 different degree changes means for our planet. Other terms you need to know about for carbon is the differences between operational carbon, embodied carbon, and also what the life cycle assessment is. So when you're talking about carbon, you also need to specify what stage of a building's life cycle you mean, because everything that we do as humans emits some amount of carbon. And as we're designing buildings, there's also different stages of carbon emissions for the project. Here, this top diagram kind of showcases the traditional 7 stages. I know this has been expanded and now there's 12 to 14 different stages depending on what standard you follow. But at a high level, you can think of the 4 stages: the product stage, construction stage, use stage, and end of life stage. The 2 that architects should be concerned most with are product stage and use stage. Product stage is the extraction of raw materials, the transportation of raw materials to a manufacturing factory, and then the manufacturing of products. Every material that we purchase, we select, has some amount of embodied carbon built into it. And in order to reduce carbon emissions for our projects, we need to be more selective about the materials we're going to choose we're going to specify. One great thing about this stage is that most manufacturers are required to calculate embodied carbon for the products that they manufacture. So we have a really good idea of how much carbon emissions are in certain products. So we can start giving an idea of what materials we need to choose for, whether our building needs to be steel, wood, concrete, what the difference is between having a 100% wood building versus part wood, part concrete, those things. And again, these are decisions architects need to make and not somebody else who's less involved in the project. The use stage is another important stage for the architect. This is operations. This is when the building is actually occupied. And this is all of the emissions caused by utilities, maintenance, replacements, things like that. So if you ran an energy analysis and you made the building efficient, it lasts on average about 70 years. Throughout the life, the 70-year life of the building, how much energy did it consume? How much carbon emissions did it emit? And if you did your job well, it is able to avoid a significant amount than what it would have done if it just was a code compliant building. The other two stages for the life cycle is the construction stage, when the building materials are getting transported to the site and its construction phase. And then the final stage is end of life, where the building is demolished, taken to landfills, recycled. And there's a couple of new stages with more recent updates to the life cycle assessment. And of course, the life cycle assessment is calculating embodied carbon for all the various stages of your building. Very few projects ever go for creating a life cycle assessment. So part of my job is also just let you know, only really worry about the product stage and use stage if you're going to be looking at embodied carbon. It can be incredibly expensive to calculate all these stages. There's a lot of tools out there that make it easier and easier. So eventually, when that's possible, definitely go out of your way to calculate a full building LCA. But as far as just having an environmental impact, majority of your carbon emissions and how you can actually impact and curb the climate impact is going to be in those two stages. And then you see some other graphics showcasing where the energy or where the majority of the carbon emissions are coming from on the operational stage and also in the product stage. So I'm just checking time. Yeah, we were pretty good. I'm second to last section. We're going to talk about a little bit about the collaborative workflow. So there's been a lot of issues, and they've been highlighted throughout the pandemic of how it's been more difficult to communicate with one another, stay on the same page. We really want to make sure that more folks are incorporating more parts of the team so we can all make decisions together. But there's been a lot of issues with lack of real-time coordination, inability to move data from one platform to another, delays, turnovers, loss of data, requiring more specialists to run different tools, and dividing the costs individually rather than sharing more of these costs to communicate and be centralized. That's really going to be an important part of being able to deliver all the different services and have more efficient buildings. So again, just incorporating more folks, the architects, the engineers, contractors, owners, consultants, letting them know what your plan is, what the goals you'd like to achieve are, and what kind of roles they can play in that process. And of course, if you are able, if you're not familiar with this graphic, this is the McLearney curve. Again, I talked about this earlier, but the traditional design process, the folks who are running analysis, they're doing it after the building's designed, typically when it's too late. If we can move that process earlier on, the more risks we can avoid, the more risks we can mitigate, and also the greater impact we can have on the project. And then a couple of other things you need to do. So I'm gonna stop there. Well, making sure you communicate with your stakeholders, understanding their budget commitments, their time commitments, what it means to go for a green building, making sure that they're not deterred by the investment, talking about return investments, the life cycle costs, all those things that I showcased earlier. Being able to showcase decisions in real time and show them what these different decisions will kind of impact they'll have, and then just adding credibility to your argument, and of course all the different supporting graphics you can generate. Cool. So in this last part, I'm going to talk about two quick case studies. So the first one is a project I worked on. This is the campus, or the CLC, I forgot what it's called, the university, Emory University Life Campus. This is a project in Emory. It was done by local architects, engineers, contractors. COTE was very early in its time. We went from being a sustainability consultancy group to starting to sell our software because we saw it become really successful. We went from 20 projects a year to 200. And one of the bigger ones was working with the Emory team and Due to Paint architects in order to make this a more efficient design. Through the different analysis we were able to do with this project, we were able to save 1 million in construction costs, and it was primarily saving on the glass and HVAC system for this building from what they were originally planning on choosing. With the different energy analysis we were able to do with the project and the optimization, we had 40% energy savings, and it was able to reach LEED Platinum. And based on surveys that we had with the architects, they were able to save 240 hours of billable time through the different design revisions that they typically see on most projects of this scale and typology. So what did that analysis look like? We started with the climate report. So just looking at different climate conditions of their site, you have the temperature, ventilation with monthly wind roses, adaptive comfort to identify some different peaks and valleys throughout your typical year, radiation benefit, and the sky dome to identify ideal locations for glazing, for additional insulation, for thermal massing, if that's something that you're interested in doing. And then the psychrometric chart to identify what are going to be some of the top performing passive strategies for our location. So we can really pinpoint which ones we should invest time in versus the ones that we don't need to worry as much about. And then benchmarking. We knew exactly what the building was going to look like. Emory has a pretty strict requirement on the design of the project. So we started with a shoebox model. That shoebox model did iterate through a couple of different designs, but it always stayed about the same shape. So we knew we're going to be, we knew what our benchmark would be, and then also what our eventual target would be. We didn't go after the 2030 target. It wasn't something that this project could do, but we did see, I think, 40% energy savings in the conclusion. So you can see the building started at a 46 CUI, no LEED points. You can see the utility costs, and currently just with the difference of a standard building and a code compliant building, we already saw 9% carbon emissions reduction. Another analysis that was conducted was the daylight analysis. I don't have all the different stages of that, but just showcasing daylight access into the building. This is a 3-story building that had a large atrium on the middle section of the building, so daylight was going to come in, but we also had to worry about how much glare would happen because of that design. So here you see really high glare levels. Ideally, you're around 20 or lower percent, but in this case, we had 30, 68, 48% areas that we would have glare conditions. We started looking at different shading strategies in order to reduce those glare conditions. So this is the rapid prototyping tool. We can explore different window shapes. So looking at, we knew 40 or 60% window to wall ratio, but looking at ribbon windows, large openings, continuous windows, and larger openings, or the 60 and 40, never mind. I was thinking of a different case study. And then just seeing what kind of daylight access that was going to allow in different classrooms. We can look at different directions. So this is the west facade. Again, just looking at combining those different strategies, what kind of daylight access they allowed. With the facade tool, you can also look at things like overhangs, fins, in order to shade those spaces. Next, we had optimization. Optimization is where you can look at multiple different material options and figure out what's going to get us the most energy efficient and cost effective conclusion. You can see for windows, we're looking at a couple of different product types. They're all from Varicon glass. We have a couple of different roof options, shading options, PV options, HVAC sensors. We ran that analysis through our optimization tool. You can see this top graph. It's a parallel coordinates graph where we list out every possible option that we want to look through. COTE runs every energy model with every combination and then generates the bundles that are going to be the top performing options. We had a baseline cost of 5 million. That's just the initial purchase of some of the building materials. The building was going to perform at a 46 EUI. That's the baseline. And then just with the first optimization, if we invested an additional 2 million, we could reduce our EUI by kBTUs, which allowed us for 22% energy savings, and some of the options we need to choose for that project. For the final bundle, after running all the different analysis, adding additional options, we shortlisted some of the other options, ranges that we would hit, and then the investment we need to make in order to select those options, and then where our EUI could finish on, so a 38 EUI. Sorry, I had to cough really quick. And also this shading structure on top of the building was something that they iterated through, but I don't really have any report graphics from that. So this whole louver system was one of those big performance factors that we were able to figure out. The second case study I'll quickly go through is the Terra Nova Ranch. So this was a really exciting project. These are organic crop producers in California. Their entire operation and business practice is about efficiency and sustainability. They want to make sure they can deliver crops when they're available. It's not something that they do every year. It's really interesting business practice. You can look them up. But sustainability wasn't necessarily something that they were thinking about for their project. So their architects, it was one of the first projects they had after they bought COTE. And one thing that they were really interested in doing is, what if we chose a really ambitious target and could we achieve it with COTE and then showcase it to the client? The client seemed pretty open-minded. Now we just needed to combine a report and present it to them and see if they'd go for it. So for this project, the building benchmarked at 48 EUI. The 2030 target was 10. So this design, they wanted to make a net zero carbon building. So just reduce all possible carbon emissions with this design. And also, I think they tried to figure out how to do net zero energy, but they weren't able, they just missed it, just right above the 0 mark. So we're going to look at a couple of the different options they have. So this is the baseline. Again, this is a code according to code minimum Title 24 in their location. Their code minimum building was a 43 EUI baseline at 12% carbon emissions reduction, which is the difference to the national average. With upgrade number 1, it was adding additional insulation. So in this design, they wanted to add 2 inches of ESP board to the walls and then 3 inches of ESP to the roof. With that investment, they were able to reduce their EUI by 5 and also have an additional carbon emissions reduction up to 20%. So that's upgrade number 1. Upgrade number 2 was better performing glazing. So they went for a solar band 72 glazing. You can see its performance metrics down there. This didn't offer as much of a benefit. It only had 1 EUI reduction, 2% additional carbon emissions reduction. Yeah, it wasn't an option that they decided to go for. Option number 3, additional PV panels. You can see the information down there. This was a huge game changer. PV panels is also always a great way to reduce energy consumption. This allowed for additional 30 EUI reduction and brought them up to 84% carbon emissions. And you can see they've already, in this case, they have beat the 2030 target. So they're now at 7 EUI. You can see that target table here. And then the last thing they did, so after adding PV, that was one of the final things that they could think of. They've involved the engineers and asked them, is there anything else we can do in order to make our building more efficient? Because you can see here that cooling and heating was one of the more dominant categories in the project. And the engineer offered to add heat recovery and ERV unit into the project in order to make that system more efficient. With that final option, they got an additional 8.5 reduction in energy consumption, and were able to go into net positive for carbon emissions. So they went with option A, B, and D. They skipped over the glazing option because it wasn't beneficial. And that's the project that the client ended up going with. And it was a 5-minute presentation. The client wasn't really ready for it, but the owner kind of presented this information, showcased them how easy it would be, and also had a lot of the cost information available, and they decided to go for it. And I think the project, it was being planned earlier this year. I don't know if it's been built and if it's operational yet. And then of course they did a couple of different 3D analysis, but we don't want to talk about that too much. Yeah, so that's everything that I wanted to share. Want to open up the floor for any questions. Yeah, thanks everyone.
Thank you, Marco. Really appreciate it. There's a few questions in the chat, and I think Matt might be running that, but in the short run, would you be able to talk a little bit about the interface of the tool and how architects might come at this, maybe starting from the beginning of like pre-design, early massing, how they might work with the tool to input that? I know that cove.tool offers a number of ways to integrate like design models, SketchUp, Revit, all of that.
Yeah, so you can start your project at any stage of design. We only have 4 requirements to start your project. And once you give us those prerequisites, we automatically populate all the different analysis. So if you know your typology, your location, your energy code, and then you can give us some idea of your geometry, that's everything we need in order to set up your energy model, the 3D analysis, water tool, climate reports, the cost versus carbon optimization, which I was showcasing. Really simple. The geometry part is always everyone's biggest concern. You have 3 options for geometry. You can do it manually. So if you don't really have time, or it's a competition, or you just don't want to invest too much to generate a report, just do a napkin sketch, calculate roof area, floor area, window wall ratio. That's enough to create a shoebox model, get some analysis. If you have an existing model, you can use any of our plugins to upload that geometry. So we do have an app store for some of the top tools that we work with in order to look at your building, get it loaded. And also, if you do want the 3D model, but you haven't made one yet, you can create it from scratch in cove.tool using our drawing tool. So you can just use different drawing elements, trace and extrude plans if you happen to have them. And then we can run through all the different analysis in Cove. And our biggest resource, like I mentioned, is our help center. We really try to be an educational juggernaut. So everything that you see in cove.tool has a help article, a video tutorial, where we explain what it is, what you're doing. That's a really important part of people actually adopting it and using these analysis. Yeah.
Thank you. Let's see, there was another question about whether or not the slides would be available after the presentation. Is that something you can share?
Yeah, I'll send the slide deck to you. I finished it a couple of hours ago, so we don't have them earlier.
Okay.
Yeah.
Marco?
Yeah, go for it.
Gary Collins.
Gary?
There's a lot of beautiful graphics being flashed here. I'm wondering if this is a program you sell that architects can learn to use, or a service you provide where the architect's work is sort of plugged into it.
Yeah, it's a product that you guys can purchase. We have a subscription plan. It's an annual plan, and then it just depends on the number of seats you want. And we also have a couple of different product lines. So maybe you don't want the entire tool, you just want specific functions. That's how we do pricing. But it's not a service anymore. We used to be a service, but now it's a product.
Are there any other questions?
Just one more observation. Marco, Gary Collins again. It looks like a tool that's really intended for fairly firms with deep personnel capabilities, doing projects that really make this worthwhile in terms of the total investment.
That's partly true, but we also want to make sure that like small firms can use these tools, that people who work on just residential projects or historical preservations, we've figured out a lot of ways to make that possible, and we've added new features so that it would work. Our goal is just to make sure as many people as possible are doing analysis. We can reduce carbon emissions, help move the industry towards that direction. And yeah, so hopefully anybody can use it. And if you need additional support, or if you're in a trial and you have questions, always feel free to reach out to me or anybody else on the team. We love to take feedback and make the tool better. There's a lot of constant updates that we're hoping for. But yeah, it ideally is designed to be as easy as possible for anybody to use.
Is it compatible with all the major CAD platforms?
Yeah, so Revit, SketchUp, Rhino, ArchiCAD, and then a couple of other ones.
Got it.
Yeah, and then there's video tutorials, articles, all that stuff.
And then Marco, can you report directly or generate reports directly from the cove.tool site for, let's say, AI 2030 reporting or tracking lead, that kind of thing? Not that you would issue something directly from the site to for lead accreditation, but just something to track measures.
Yeah, so for the 2030 question, we do have a button that you can click that automatically reports your information to the DDS. You have to set it up with your admin in order to do it, and then update it at every couple of days in order to like make the plugin work, because it's on an API that expires every 24 hours. But yeah, you can just do it with a click of a button. And for lead points, we have tutorials on how to get everything into a calculator. We don't automatically export the reports and calculators you need to fill out, but there's ways to just like manually copy and paste that information to a calculator. And then there's a lot of lead point calculators to let you know how many points is this design currently getting us. So you can always track that and, you know, make sure like, are we getting a certain value, that kind of stuff.
Perfect.
Yeah.
Well, thank you so much for coming in and doing this presentation. We really appreciate it. And thanks for everyone that joined in to listen in.
Yeah, no problem. Thanks, everyone.